All right, we're going to do percent compositions today, so don't let me down. I know it's been Thanksgiving and everybody ate too much tryptophan, but I'm not a fan of tryptophan. Tryptophan. Yeah. That's what you do if you're at a baseball game and one of the fans is running down the aisle and you trip him. You would be tryptophan.
Oh, I get it.
There you go. It's not spelled the same, but it's still very similar. All right, percentage composition. I know you've had a lot of days off here, 4 days off, 5 days off.
I might run out of paper.
That's okay. But I'm going to ask you how we're going to get the percentage. And I need you to think. Okay? Okay, first of all, I want the percentage composition of a compound. For example, salt. You guys probably look up, maybe you don't, but if you've ever seen on your candy bars or pretty much anything you buy nowadays on the nutrition labels, they'll have the percentage a lot of times, or the grams of sodium, potassium, whatever it's talking about, sugar. Okay, how would it get sodium? Okay, is it going to be the grams of the salt? Well, no, because salt contains what? Sodium chloride, right? So if I wanted to find out the percentage of salt that's actually sodium, how would I do it? That's what I'm asking, because that's what I'm going to be doing in percentage composition of compounds. We learned how to write the compounds and name the compounds last week. We even did molar mass last week. Told you we're going to be doing more calculations with compounds. We have a lab tomorrow. You have a single tomorrow, but we're going to get it started at the second half of next period. Okay? So we're going to actually start the lab, get stuff ready for it, and I'm going to really do a calculation. You're going to do a calculation for it. But basically, my question is, how would I get the percentage of sodium? How much of salt is sodium? Okay, what would I do? And using the periodic table, it's a very simple calculation. Think. This is where it requires thinking. It's one of the problems you guys last period had. I know you've been off for a little while, but we did percentages before. Where have we seen percentage before? Where? Percentage what? Percent error. I talked about percent in water and a popcorn. Remember in the kernels we did? I talked, in both of those cases, I used as an example, what if I wanted the percentage of girls in the class? What if I had 10 questions right out of 20? What would your percentage be? And you could answer all those questions. Now, having done all of that, can somebody tell me, if I want to know, here's salt, here's NaCl, using the periodic table, could you tell me the percent of salt that's actually sodium? What would you do? Think. Raise your hand. What do you think? Will you raise your hand, Ben, or no?
Sure.
Go ahead.
You would subtract atomic masses from each other?
I wouldn't subtract them. Wouldn't have to. What do you think?
Would you add them together and then divide Na by the total?
Exactly. What's sodium's mass? Look up there. What is it? 22.990, right? Everybody see that? That's his mass. What's the mass of this whole thing called, by the way? The whole compound. What's that called? We got to get last one. The molar mass. The molar mass would be that plus chlorine, right? Right? So it would just be the mass of sodium over the mass of NaCl. Now, if you don't, and why everyone's hand wasn't like, oh yeah, that's easy. It's just as easy when I'm sure everybody knew, percentage of girls in the class, you knew exactly what to do. It's the same thing. It's always the same thing. It's the part over the whole times 100, right? That's what you always do. Okay? I got 10 questions right. There were 20 questions on the quiz. 10 over 20 times 100. What percentage did you get? 50%. Percent error. Part that's in error. EA, that's the error. Over the accepted, that's the whole value. Times 100. That's how you get percent. And this is, as I'm looking out there, I realize people are like, oh yeah, okay. This is the difference between really thinking and learning versus memorization. Okay? Being able to apply your knowledge from one area to a new area, where all I changed was what I'm getting the percentage of. Okay? You should all be able to do that, because percent shouldn't be something where, oh, I remember that. It's EA over 8 AC times 100. No, it should be the part That's an error over the whole amount times 100. It's just like this is sodium, which is a part over the whole amount times 100. It shouldn't be a memorization thing. It should be an understanding thing. So anyway, either way, whether or not you got that, hopefully you do, because it will come up again. We'll see percentages again. Percent composition is simply the percentage by mass of each element in a compound. And the formula is exactly what the formula is. If you want to get the percentage of garbage in a garbage can, you want to get the percentage of people in a class, girls versus boys, it's the same formula. Part over the whole times 100. The part that you're trying to get the percentage of, divided by the total amount or mass, and then multiply by 100%. And by the way, in this specific case, here's what it will look like. The part will be the mass of sodium, the mass of the element. The whole will be, what do we call that? The mass of the whole compound is called, we learned last week? Molar mass, and then times by 100. All right. Now, the sad part is, although I went over that again, the next time I ask for percentage, I'm going to get the same exact thing. And matter of fact, the next time it comes up in your everyday life. And by the way, percentages do come up in your everyday life. I hear this all the time. If I don't give many quizzes or worksheets that aren't worth a very 10 most of the time, right? Maybe 20. So it's pretty easy to get percentages. But every now and then you'll get a quiz or a test that's worth 40 points, and you'll get a 32 out of 40. What is that? You'll have to ask me. What is that? What's that? What's the percent? You don't have to ask me that, right? If you got 32 right out of 40 questions, what are you going to do to get your percentage?
I'm going 100.
No, you're not going to divide by 100.
32
32 over
over
40 times 100.
Yeah.
Yes. Okay. All right. So, I mean, it comes up all the time, percentages, and hopefully you'll know that. But either way, even if you don't, I always kind of end this way when I'm starting a concept. That's all you need to know. And so, if you can do what I'm about to do with the two examples I'm going to do, you can do these problems. First example. I want you to find a percent, and I told you I'd stick with an easy one here, salt, first, of NaCl. And I want you to do it for both elements, sodium and chlorine. Now, I've got this one worked out for you, but I'm going to break it up into two parts, okay? Most of the time, the part and the whole, you can just look at it and divide them. But you can't really do that for compounds, especially when you get a compound like, NH4,2SO3. I mean, that's tough. The mass of all these guys added together, can't really do that in your head. So, you know what I'm going to have you do first? I'm going to have you find the molar mass first. Scared me. Not that much, but all right, I overacted a little bit. All right. Find the molar mass first, okay? So again, I have this one worked out for you. You don't have to look ahead. I've got this. What are you going to do to get the molar mass of Na and Cl?
You're going to find the mass of Na and Cl and then add together.
Exactly. Find the mass of Na and Cl and add them together. All right? Because there's not even any subscripts. But to follow the procedure of what you would do if it were a harder one, you'd write that chart out, you would do that, and you would add them up and get that. So copy all that down. And we've done all this, right? I mean, that's not the reason I'm doing this faster now is that we spent several days on it last week. Before we even got to molar conversions, we did this. So we actually did it for I think it was before last week. It was actually it was the previous Thursday and Friday we did this, because on Monday we did conversions, and then we did a lab on the candle on Tuesday, right?
Mm-hmm.
So yeah. So we don't really need to do this, explain it again. You should all understand this. Now, guys, you're not done. That's the whole. That's the total. Part over the whole times 100. That's what I got to do. That's the bottom. That's the denominator. That's the whole. Now, I have to divide the mass of each of those elements over that mass. So let's do that part next. Y'all have that copied? That good? Hurry up. Okay. So for sodium, to get the percentage of sodium, well, here, just write that down first. After you write that down, what are you going to divide to get the percentage of sodium? What? Give me the numbers you're going to do. Look at your Look at your notes there. What are you going to divide? Mark, what do you think?
22.99.
Divided by?
58.
Exactly. And then times by 100. Exactly. And you get 39.337%. What are you going to do to get chlorines? 35.453, right? Divided by the same number, 58.443, times it by 100, and you will get 60%, 60.663%. And that is your answer. Okay? So your answer to the question, what's the percentage composition of sodium chloride, is sodium is this, there's this much sodium in sodium chloride, or is that much chlorine in sodium chloride? I have a little line underneath this. Somebody probably may be thinking to themselves, what might happen if I added these two up? What would it come out to be? Exactly. Now, I want you to write the 100 down there and add them up, but that is not your answer. That's just a check to see if you did it right. You'll kind of know you did this one right, pretty much, if when you are done, your two percentages add up to 100. You'll know you didn't make a mistake, at least with the calculation, with the arithmetic. There are still mistakes you could make. You could have written the compound wrong, all right? And there's other things you could have done wrong. But for the most part, you'll know if it does not add up to 100, or very, very close to 100, you did it wrong. All right, everybody go with that? Now let's do a harder one. And how can I make this harder? Well, obviously, what would I do?
Add subgroups.
Yeah. Multiple elements, and so I heard both. More than two elements and subscripts on them, and probably parentheses and all that stuff. Let's do that. This will be the one we'll do here. I'm only going to do one other example, and I'm done. You'll have the rest of this period, and even some of next period, probably about, I don't know, maybe a third of next period or a half, to do the homework. It may not look like much, 33 and 35, two problems only. Yeah, but guess what? Each problem will be this long, and there are A, B, C, Ds to them. So it's not just two problems. And that's for practice, so you don't make the mistakes. And I'm going to point out to you, there are several mistakes I'm going to point out to you. I hope I hear them. I got them in the last period, and I want to get them now, so we'll see. First thing first, I cannot begin this problem until I know what about aluminum sulfate?
You need to know the name.
I have a name. I need to know the.
No, you need to know the.
Begins with an F.
No,
Formula.
the formula.
Yeah, I need to know the formula. All right, so.
I was say no.
Not that F word, Emily.
Uh-huh.
All right, get your common ion sheet out, and let's review. What are we going to review? We're going to review how to name compounds again. How to write formulas for compounds again. All right. First things first. I look at the name, aluminum sulfate. Uh-oh, it ends in 8. That tells me right away it's a ternary compound. So I look over here. 8s are on the sheet. They're easy. So I look up the symbol and charge of aluminum. What's the symbol and charge of just aluminum now? Aluminum.
It is.
Wait. What other? L. What's the symbol of aluminum?
Al.
Al. Okay. Did I hit the button yet? Or no? Yeah, I did. Al. Charge? Plus 3. Sulfate. You got your common ion sheet, everybody?
That's a 4.
You're so fast.
I'm the girl on fire.
Thank
That is
you.
somebody-
Catnip. Yeah. All right.
And it's a -2.
Thank you. Beat ya. I already got nothing. All right. I got a plus 3 to my 2, and I'm not telling, I can't stress this enough. How many people on the test will go through all the trouble of looking up these guys, writing the charge, looking up this guy, writing the charge, having it all right, and then leaving it like that? What do you have to do now? Balance it out, right? Happens all the time. That's why we're doing practice problems. That's why we did that little quiz last week, or 2 weeks ago. And it's why you're going to have a review probably I don't know, Monday or Tuesday of next week. All right. That's the first step. What am I going to do next?
You have to find the molar mass.
Right. I'm not going to write that all out again. I'm just going to do it. Okay, so element, number of atoms, times the atomic mass equals the total mass. And then we'll add them all up, okay? So, first things first, before you start getting ahead, because people, this class, especially classes like this, tend to like to work ahead. While you're still listening and not working ahead, then I'm going to give you different jobs to do. How many aluminum, we have aluminum, sulfur, and oxygen are the elements. How many aluminums, Josh, do I have?
2.
2, okay? How many sulfurs do I have here? See why it's 3? Parentheses 3. 3 gets distributed like it would in a math class. I've got 3. And how many O's do I have?
12.
3 times 4 is 12. Good. All right. Now, I need you to help me out here as I write these down. You have to have your calculator in front of me and do these. I don't have this answer for me. So aluminum's mass is 26.982. Jared, why don't you do that one for me? And while he's doing that, let's set up the next one. Sulfur's is 32.066. And we'll have Marvin's do that one. You have a calculator? Do that one for me. And then I got 12 times 15.999. And Bo, you got a calculator? Do that one for me. And we'll write all those down. Let's start with aluminum. Who got aluminum? Parent, what'd you get?
53.964.
53.964 grams. Okay. And who had the second one? What do you got? 96.198. And the last one, what'd you get for oxygen?
191.99.
Yeah, and notice he already rounded it off to the correct significant figures. There's actually more numbers than that on the calculator screen, but you round that one off to 2, I mean to 5, because he has 5. So he should have 5 in his answer. I add all those guys up. Everybody should do that so we make sure we have the right numbers, and we'll see if we all get the same answer. Add all those up. And Zach, what'd you get?
342.15.
342.15. Everybody else get that? Sound good? All right, good. Now, that's the first step. That's the whole. Now, let's do the part over the whole times 100. You realize I'm not done now. Okay? Oops. I want to get black this time here. All right. What's my next step? I got to take each of those guys, aluminum, sulfurs, and oxygens, and figure out their percentages. So let's start with aluminum. Here's Al. Percent of aluminum. Whoops. Don't do that. Percent of aluminum. What? Everybody look up here. What 2 numbers am I going to divide to get the percentage of aluminum? Tell me that. What 2 numbers? Ronnie, what do you think?
The 53.964.
This guy right here? Correct. Was anybody thinking this one? Because that happened in your class. That's one of the mistakes I saw. I was hoping someone will make it here, but that's okay. Good. 53.964 over 342.15 times 100 gives me, let's see, Ellie, you do that one. For percent of sulfur, what will I divide there, Karen?
96.190.
Over 342.15 times 100. And do the math for that one, Maddie. And while she's doing that, what's the percentage of oxygen in this guy? What am I going to divide for this one here? Rebecca.
191.99 over 342.15.
Okay. And do the math for that one, Jared. All right, let's go back to aluminum. What we got that one? 15.772. Is that right? Percent? Okay. How about for sulfur? Who did sulfur for me?
28.115.
Okay. And oxygen? Who did that one?
Jerry.
56.113.
Now, I don't know if they're right, but I'll have a good way of telling in a minute. What should they all add up to be? About
100%.
About 100. What do they come out to be? Add them up.
100.
Exactly 100? 100. Now, don't be surprised. The other class, whatever numbers they gave me, you know what the answer came out to be? 99.999. Now, that means that at some point or another, when they rounded off here or wherever, they may have rounded up or down or used the numbers without rounding them off before or after. And so that might happen. It's not wrong. I'm not going to take off. If you got answers that come out to be 99.999 or 100.002, that's fine. Okay? Don't go back and redo the whole problem over again. But it should be very, very close to 100, like this guy is exactly 100. All right. I want to, before you let you start, I have a couple of things to point out to you. Two things. One is a trick that you can use to make these problems go faster. Okay, let me show you the trick first. You get all these things done. Notice you're repeating the same number here, 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 and here. And you guys are all really good at texting, okay? And you've learned over the years, you don't have to write out you, Y-O-U. You know, you just write you, the letter. It's a lot quicker. And everybody knows what you mean. Well, I got a little abbreviation for you here. If you learn how to use this button on your calculator, it will help you. It will save you some time. To type in 342.15 each time is to type in 6 keystrokes. 342.15, 6 keystrokes. Here, here, and here, after having gotten it there. Now, I'm telling you, you can avoid that if you just use your memory or store button, wherever it says in your calculator. Now, it's different for different calculators. You'll have to figure it out on your own. I'm not going to, but here's what the advantage will be. Watch this. When I go to divide this guy, all I'll have to do is hit 53.964 divided by recall. That's it. Or memory 1, or whatever your calculator says. And when I do this one, the same thing, divided by recall, 1 button. Divided by recall, 1 button. So instead of hitting 6 times 3, 18 strokes, 18 button pushes, I would have 1, 2, 3 button pushes. You see? Because you're going to get this as your answer anyway from over here when you add them up. All right? So you could store the answer in your calculator and then try to. You might want to play with that over the next couple of days and see if you can figure it out. Yeah, I'm not going to teach it to you. I'm looking out there and it looks to me like there's at least 6 different calculators out there. At least, probably more like 7 or 8. I'm not going to find it. I don't know how to use all yours. But if you find it, it will be worth your while. Because think about it. In tonight's homework alone, you've got 10 problems. Because it's A, B, C, D, E to each one of those. 10 problems. Each one of them about that long will be 18 strokes versus 3. That's 15. 15 times. It's 150 less buttons to push on your calculator in one homework assignment. So it's definitely worth your while if you want to figure it out. Now, hey, look up here. Last thing to tell you. Okay? I just want to summarize one other thing. How chemistry builds. How much have we used in this chapter? This one problem. What's on the board right here? There's stuff from significant figures, chapter 2, right? Percentages, we originally saw 2 other times. Percent of water and popcorn, percent air. Where did we learn how to do molar masses? 2 weeks ago, right? Where did we learn how to write these compounds? 2 weeks ago. How do we know aluminum's +3 and losing and gaining 3 electrons octet rule over the course of chapters 5 and 6? There's pretty much something from every chapter on the board up here right now. All right? That's not going to go away. Believe it or not, what I have up here, next chapter, you're just going to be using as part of doing stoichiometry. All right? Where you'll put it together with something else you're going to learn. It doesn't go away. All right? So, good enough. Let's start on the